this video, I'm going to demonstrate how to record the UV-Vis spectrum of a red dye 40 solution. And from that measurement, we will be able to determine the concentration of the actual solution. For this experiment, we're going to need some instrumentation. And for today, that will be the vernier spectrophotometer. We also need to connect to a device. And for today, I will be using my iPad. We will need 2 cuvettes, one for the calibration that will contain water, and another one to contain our sample, which will have our stock solution. Here are our 2 cuvettes, and it is important that whenever you're handling your cuvettes, you always touch the ridged side and not the clear side. And we also need 2 caps for those cuvettes. We'll need our stock solution of a red 40 dye. We will need some deionized water. And if our hands are not steady, or if it's strange to pour from the volumetric flask, you can always use a pipette. So let's get us started. The first thing we're going to do is get into our spectral analyzer software. And that may already have some data, but it is important that we connect to a spectrophotometer first. When our spectrophotometer is turned on, there will be a green dot next to the power button and a pulsing blue light next to the Bluetooth function. When that is pulsing, it is available for connection to your device. And that could be either an Android or an Apple device. You simply connect to it. It will recognize the spectrophotometer, and you will know that your connection is established when that blue light becomes stable. Then you click done, and you are ready for the next step. If you already have someone's data open on your device, then all you have to do is click connect, and it will say calibrate. And then you have to wait a couple seconds for your lamp to warm up on the spectrophotometer. As that is happening, it is a good time for you to prepare your reference. And that means taking your cuvette, filling it about 3/4 of the way with water, and then placing the cap on top of the cuvette. The first message that you will get once the lamp is warmed up is for you to insert your blank. And the blank means the cuvette with the water. When it is ready, it says, place a blank cuvette in the device, and you want to place that cuvette with the clear sides along the light. And with that, you press finish calibration, and you wait a couple more seconds. The next step is going to be recording your spectrum. So you transfer some of your stock solution into your cuvette, approximately 3/4 of the way full, and just like with the water, you place the cap on top. Click on New Experiment. If there is something that is not yours, it is not your responsibility to save it. So at that point, you say, don't save. But your data, the one that you're collecting and you want to keep, you should save that. Next, we're going to go to absorbance. We're going to extract our blank and place our sample with the clear side on the path of the beam. Next, we're going to click on absorbance, and under absorbance, we will see 3 different functions. The first that we're going to press is versus wavelength, full spectrum. And once we're there, we click collect. And very quickly, a spectrum appears. At that point, we can press stop. And on the right side in this case, or underneath, if you are positioning your device in a different orientation, you will see your data set. On the right side, you will have all your wavelength and all your absorbance values. And you can follow that data set and identify which wavelength corresponds to the highest absorbance value. Or you can look at your spectrum and click on it, and it will give you this line that you can place wherever you touch your screen. And so it is very clear from this graph that my highest absorbance value will be associated with a number around the 500 nanometer wavelength. And once that line is there, the data set is going to show us the wavelength and the absorbance in that region. And as we look through it, it is very clear that in our case, the highest absorbance value will be around the 503 nanometer mark. This is very important because from now on, if we are to do a Beer's Law experiment or a kinetics experiment, and we want to trace the changes associated with the concentration of the dye, we need to be very careful to monitor the wavelength that is associated with the highest absorbance value.